Okay, moving right along, let's dive into method of sections here. So method of sections is fantastic where we don't really want to know or need to know the member force in every part of the truss. Let's say we're going to keep in our drawing, we're going to keep this member the same the whole length, and it's going to actually be continuous. Same with this. And then maybe we want to keep all of these web members the same. In a truss, the maximum stress is going to be in the middle for the chords, so top and bottom, the maximum forces, depending on the loading, but generally speaking, will be in the middle. The maximum diagonal forces are going to be at the end. So if let's say I'm estimating the weight of this truss, it's early in a project, the contractor's like, hey, I just want to know roughly how much this animal is going to cost. I could do a method of sections right through here, find the weight of those chords once I know the force in them. Then I could do a method of joints or a method of sections and get that member size. And then I can say, okay, all the webs are going to be based on this. All the chords are going to be based on that. It's going to err on the little bit of the heavy side, but that's okay. It gives people a quick way to start. Another thing I can do is use this method quickly to check the results of a finite element model. It's always nice to be able to say, okay, I've done this complex model in the software. There's a lot going on. There's ways to screw it up. I'm just going to go back to a basic principle that I learned in school that I can quickly say, hey, are things correct? Okay, so with that understanding, when we do method of sections, we're going to take a chunk of the truss and draw a free body diagram, and we're going to cut through a part of it that interests us. So what I've done is said, okay, I'm interested in this portion, especially right where that line is. This is now my free body. So anywhere I had a member that I cut through, I have to replace it with a force along the length of that member, so parallel to that member. It's okay to guess which direction the forces are going to be, but if you don't know, just draw an arrow a direction. And if the number comes out as a negative, then you know the arrow is going the opposite direction than what you drew it. And you don't even have to go back and change it. You can just say, oh, I drew this that way. My number is negative, so I really know that that member is in tension because the force is pulling on it rather than pushing on it. Couple key things. Well, the next step, and maybe I have a different slide here. Okay, yeah. The next step is we're going to sum moments about a point where the forces intersect. So this force intersects with this force right at B. If I sum moments about here, these two have no effect on the sum of moments because they have zero moment arm. This one is left, and I have one unknown in my equation. Similarly, I can come out here off of the truss section and say, okay, FIH and FBH intersect out here at point H. I can sum moments about here, and I'm left with just one unknown. So the main point I want to make with this is it is okay and even necessary to sum moments about a point that's not even on the free body. That's totally legitimate, and the math still works out just fine. If you learn nothing else from me today, learn that you can do that. Okay, once I've summed moments about 2 points, then I'm going to sum forces either in the vertical or the horizontal direction to come up with my final solution. And just looking at this, probably would need to sum, well, best in the vertical because then these two don't show up. You just have that and the reaction and the input forces. Okay, I've given you a handful, or not a handful, 2 examples. Cutting through here, drawing the free body. This is a little more complex than some of that geometry, but if you look at where FGF projects out when it hits this horizontal line at FCD, that's way out here. And based on the geometry of things, we can find the angles and work through things. Also in that Truss chapter I gave you, there's an entire section on method of sections that you can jump into and start working through things. And just for grins, because I think it's so cool, there's a section on the graphical method and how one can use that to solve. Okay, I think that's it. Dive into things and